guys, and welcome to a new video. In this video I would like to go on with our maths videos, and I would like to talk about inequalities. So we are going to solve a couple of inequalities, and the first one is the following: x squared minus 5x plus 6 greater than or equal to 0. Okay, so we have to solve this inequality. We have a second order polynomial because we have here x squared, and the idea here is to find the values of x such that this polynomial is, as we said, greater than or equal to 0. So first of all, we need to factor the polynomial, and we already know how to factor a polynomial of this kind. The idea is to write this polynomial as the product between x plus p and x plus q, still greater than or equal to 0. And p and q are two integer numbers, such that the product p times q is 6 and the sum p plus q is minus 5. So we have to find these two numbers, and the two numbers are minus 2 and minus 3. So we can write, for example, p minus 2 and q minus 3. Okay, so that means that our inequality can be written as x minus 2 times x minus 3 greater or equal to 0. Okay, so for now we didn't do anything new. We just factored the polynomial here as the product of two terms. But now the idea here is to find x, the values of x for which this product is greater than or equal to 0. So the idea is to study the sign of this first term and the sign of this second term, because we obviously don't know the sign of this and this, because here we have x in it. So we have to study it in order to know the sign. So first of all we can study the sign of x minus 2, and that means that we have to ask ourselves where x minus 2 is greater than or equal to 0. So if we consider this simple inequality, we get that this term is greater than or equal to 0 when x is greater than or equal to 2. Okay, so that means that if we consider a straight line, this straight line basically reflects the real numbers, and then we consider for example here we can say that on the right of this number this term is positive, and in contrast on the left this term is negative. So because of this we usually draw plus here and minus here just to show that this term is positive on the this one greater than or equal to 0, it means x greater than or equal to 3. And this means that if we again draw this line, we then consider 3, and then we have plus on the right and minus on the left. So in conclusion, thanks to these two number lines, we know where this first term is positive and negative, and where this term is positive and negative. However, we want to get to know the sign of the product of these two terms, and because of this, we have to consider the three regions here that we can build from these two lines. So here, basically, thanks to these two lines, we now know the sign of this term and this term, but here we have to take into account the sign of the product. So in order to know the sign of the product, we have to resort to the rules of signs. So that means that when we multiply, we consider the product between a positive number and a positive number, we get a positive number, and the same when the two numbers are negative. And if instead the two numbers have opposite signs, we get a minus, so we get a negative number. So here I highlighted the three regions that we can create from these two lines, from these two number lines. And here in this first region, we have that the first term is positive, and then the second term is positive. So that means that the product is positive, and here we can draw plus. That symbolizes the fact that the product is positive. Here in this second region, we have that the first term is positive and the second is negative, so the product would be negative, so minus. And here the product is positive. In conclusion, here we have in this last line at the bottom, we have the sign of the product. So that means that since we have to consider the regions in which the product is positive or 0, we will have to consider these two regions, the regions between minus infinity and 2, and the region between 3 and plus infinity. So this final solution will be minus infinity plus 2, and then we have to consider a square bracket, because it has to be taken into account, because 2 is the value for which this product is 0, so it has to be in the solutions. And then we have also to consider, as we said, the region between 3 and minus and plus infinity. Okay, so to sum up, we studied the product, the sign of these two terms. After factorizing the polynomial, we saw that the sign of the two terms is as here, as we drew here, and then we consider the product of the two terms taking into account the fact that the sign changes. So the sign of the first term changes here and the sign of the second term changes here. So that means that also the sign of the product changes, but we have to take the positive regions, just the positive regions. Okay, so we can move on to the second exercise. Over x plus 2 greater than 0. So the idea here is again to study the signs, the sign of these two terms, so the sign of the numerator and the sign of the denominator. And again, we have to consider the regions in which the ratio is positive in this case, because here we have greater than 0. So that means that first of all we have to consider x minus 1 greater than 0. So here we are studying the sign of the numerator, and here we are asking ourselves where the numerator is positive. So the numerator is positive when x is greater than 1. So here. And as far as the denominator is concerned, we have x plus 2 greater than 0. And here the denominator is greater than 0 when x is greater than minus 2. So again, we can draw two number lines, and we have to highlight 1 here and minus 2 here. And as we did previously in the first exercise, we can highlight 3 regions. So we know that numerator is positive when x is greater than 1. So it means that here the numerator is positive and here is negative. And then we have that the denominator is positive when x is greater than minus 2. So here the denominator is positive, denominator is negative. So the final result, the sign, the sign of the ratio will be plus times plus. It gives us plus, so positive, minus over plus, or minus times plus. The result is minus in both cases, and then we have plus again. So here again we have to consider the external regions. So it means that the final solution is between minus infinity and minus 2. And now we have to consider this kind of brackets, because 2 and 1 have to be excluded from the solutions, since minus 2 has to be excluded, because here we can't divide by 0, but we have to exclude also 1, because here the inequality says greater than 0, just greater than 0, not equal to 0. So it means that the solution are from minus infinity to minus 2, and then from 1 to plus infinity. As final exercise, we consider the following inequality. So x squared minus 9 less than 0. This last exercise we have a polynomial x squared minus 9, and we have to find the values of x such that this polynomial is negative. So again, we can consider the factorization of this polynomial as x minus 3 times x plus 3 less than 0. We have to study the sign of these two terms. So the idea is to study sign of x minus 3, and x minus 3 is greater than 0 when x is greater than 3. So it means that if we consider 3 here, we can draw plus here and minus here, and then we can do the same with minus 3. With this term, we would get minus 3 here, positive, positive and negative. So it means that the final result will be positive, negative and again positive. So now in this case we have to consider the values for which this polynomial is negative. So in this case we have to consider this region between minus 3 and 3, because here the product is negative. So the final solution will be between minus 3 and 3, with the two numbers minus 3 and plus 3 excluded, because we are focusing only on the values for which the polynomial is such that the polynomial is less than 0 and not equal to 0. So we can notice also that this region is the region in which the correspondent parabola is negative, because the correspondent parabola would be something like this. So a parabola with a here the coefficient positive, so the parabola would be of this kind, with the intersections being minus and plus 3. So we notice that here the parabola is positive and here is negative, so we have to take this region because we are interested